Good day everyone. Today I'm going to discuss and share to you my insight about one of the most interesting topic in modern physics, the de Broglie hypothesis. De Broglie's hypothesis proposed that all matters exhibits wave-like properties and relates the observed wavelength to its momentum. So after Albert Einstein photon theory became accepted, the question became whether this was true only on light or whether material objects also exhibit wave-like behavior. So, here is how the Broglie hypothesis was developed.
De Broglie's hypothesis.
The French physicist Louis de Broglie made a bold assertion. He proposed that particles also have wave-like properties. Although he did not have the ability to test this hypothesis at that time, he derived an equation to prove it. Considering Einstein's relationship of wavelength to momentum, de Broglie proposed that this relationship would determine the wavelength of any matter in relationship. Lambda is equals to h over p, which is h is the Planck's constant. This wavelength is called the de Broglie wavelength. The reason it chose the momentum equation over the energy equation is that it wasn't clear with the matter whether E should be total energy, kinetic energy, or total relativistic energy. For photons, they are all the same, but not so for matter. Assuming the momentum relationship, however, allowed the derivation of similar de Broglie relationship for frequency using the kinetic energy. So frequency is equals to kinetic energy over h, which is the Planck's constant. We have here the de Broglie equation. So lambda is equals to h over mv, where lambda is wavelength, h is Planck's constant, m is the mass of particle moving at a velocity. So we have here the experimental confirmation about the de Broglie's hypothesis. So it was verified when matter waves were observed in George Paget Thomson's cathode ray diffraction experiment and the Davison-Germer experiment in 1927, where they fired electrons at a crystalline nickel target. The resulting diffraction pattern matched the prediction of the de Broglie wavelength. Since then, the de Broglie equation has been shown to apply to elementary particles, neutral atoms, and molecules. Lastly, we have here the significance of the de Broglie hypothesis. So, the de Broglie hypothesis showed that a wave-particle duality was not merely an aberrant behavior of light, but rather was a fundamental principle exhibited by both radiation and matter. As such, it becomes possible to use wave equations to describe material behavior, so long as one properly applies the de Broglie wavelength. This would prove crucial to the development of quantum mechanics. It is now an integral part of the theory of atomic structure and particle physics.
So, that's all for de Broglie's hypothesis. I hope you have learned something. Thank you for watching. Stay safe and God bless us all.